A ship is traveling west at 24 kilometers an hour. A ship A is traveling north at 32 kilometers an hour. At a certain instance, ship B is 8 kilometers northeast of ship A. Find the velocity of ship A relative to ship B. Anybody know, is it phi BA or phi AB we're looking for? AB. A is the object, and the second letter is what is it relative to? It's relative to B. Is that alright? Now, phi AB. Okay. So, phi AB equals phi A minus phi B. Can anybody tell me what phi A is? Traveling north at 32. 32J. Can anybody tell me what phi B is? Sorry? Minus 24I. Can anybody next tell me what phi A minus phi B is? 32J minus 24I, which is 24I plus 32J. Guess how many marks that went for? 10. 10 full marks. Okay. Calculate the length of time to the nearest minute for which the ships are less than or equal to 8 kilometers apart. Now let me show you next, guys. So what we're going to do is we have a diagram. Okay. So the diagram we have, that's all I need. Just that part there. Be economical with the space here. Okay, so let's draw a diagram. Northeast. B is northeast of A. So B is here, A is here. Let's draw a line linking both of them together. This line will work out perfectly here. Roughly 45-degree angle. Okay, now remember what phi AB means is phi AB means you're keeping ship B fixed. Ship B cannot move. So what you're doing is you're going to draw like a little circle here, and B is now stuck to the spot. Because B is stuck to the spot, we're now going to examine what way A moves relative to it. So what we're going to do is we're going to figure out some angles, and we're going to figure out a velocity. Phi AB is 24 across, 32 up. Let's figure out the angle here. Angle X we'll call it. Tan X equals 32 over 24. What is tan inverse 32 over 24? 53.13. Next part. What is the hypotenuse of this? Do Pythagoras' theorem. Call it y. Y squared equals 24 squared plus 32 squared. Figure out what y is. Y is going to equal 40. Now you know a lot about your magnitude. Your magnitude, or I can write like this: phi AB is 40, and then my angle is east 53.13 degrees north. I'll have 15 out of 30, 50% right now. Okay, guys. So now that I've done that, what I want to do next is this. Just bring this down a little bit more. Okay, guys. So A is moving at a speed at an angle 53 degrees. So look, if I draw another diagram like this, I'm going to draw another diagram. You ready, guys? I'm up 45 degrees. 45 degrees isn't enough. I'm meant to go up 53 degrees. Remember that you're at your closest distance. Does it want the closest distance, or what does it want? It wants to calculate the length of time to the nearest minute for which ships are less than or equal to 8 kilometers apart. Okay, so this here would be your closest distance, 90-degree angle straight down. the 90-degree angle being here. Is everybody right with that? Oh, wait a second. No, we got that wrong. The 90-degree angle being here. I haven't done this in a while. Okay. That would be the shortest distance if we're asked a shortest distance question. We're not being asked a shortest distance question. Can anybody tell me what angle this is here? That's 45, and this is 53.13, which makes that small angle in there 8.13. Okay, 8.13. Now, how far are they away from each other at the start? They're 8 kilometers away at the start. So this blue line is 8 kilometers. Are we happy enough with that? 8 kilometers, okay? Now, what happens out the other side is that, I have to grab this diagram, bring it down. What happens with this diagram is that your ship is going to continue through. So this green line is going to continue through, and you're going to keep going, and then you're going to be another 8 kilometers out the other side. So, because you have to remain within 8 kilometers. So, initially you're 8 kilometers away, and remember B is fixed to the spot. A travelled slightly towards B, then it meets at its closest point, which is usually at 90 degrees, okay? And then you keep going through until you're back out another 8 kilometers away from B. So A moves from point 1 to point 2 relative to B. Does that make sense? So you have to stay within your 8 kilometers. What type of triangle is this? The green line and the two blues. Isosceles. The green and the two blues. The black doesn't matter. So just pretend this isn't here. That's only for closest approach. That's not here. I can't get rid of it, but don't mind the black lines, just the green and two blues. Okay. So what we have here is 8 here, and we know that this is 8.13. What does it make this angle here then? 180 minus 8.13 minus another 8.13. Once you take both of them away, you're going to get 163.75. So this angle here is my 163.75. 0.74. Okay, I have to find out what is this green line here. How much distance did A travel relative to B while it was still within 8 kilometers of B? So it travels along this path here, and at any point you can draw a red line back to B. And these red lines back to B are going to be less than 8 kilometers long. Hence you're within 8 kilometers, okay? So can anybody tell me, how do I find the length of the green line? What rule would be a good rule to use there? Cosine rule? You could do the sine rule. You could do the sine rule as well. Both would work. I just tend to use the cosine rule a wee bit. A squared equals 8 squared plus 8 squared minus 2 times 8 times 8 cos 163.74. Put all of that into the calculator, you get A squared equals 250.88, and then X or A will equal 15.84. This means you travelled 15.84 kilometers. 15.84 kilometers between this here and this here. That's the distance you travelled to remain within 8 kilometers. That's not how far you travelled. How far did you travel? Oh, sorry, how long were you travelling? So how fast did we cover this distance in? This 15.84 kilometers. How fast were we travelling along this direction? We're travelling to 40. 15.84 divided by 40 will get you 0.396 of an hour. 0.396 of an hour multiplied by 60, and you're going to get 23 minutes 45 seconds. Round that off to 24 minutes. Okay guys.